Welcome to the Unravel View channel, exploring the wonders of our world and beyond. Why is Earth's sky blue? The answer lies in our atmosphere, a blanket of air filled with tiny molecules. Sunlight, a mix of all colors, enters this blanket and collides with gas molecules. Blue light, with its short wavelength, scatters in all directions. This is called Rayleigh scattering. That scattered blue light is what we see when we look up. At sunset, sunlight travels through more atmosphere, scattering away blue and letting reds and oranges dominate. Without our atmosphere, the sky would be black, even during the day. Our atmosphere doesn't just protect us, it paints our world with color. The blue sky is a signature of Earth, a daily reminder of the science happening above us. Now imagine standing on the moon. The vast, desolate landscape stretches out before you, a stark contrast to the vibrant, bustling world you left behind. The sun blazes fiercely, casting sharp shadows, but the sky above is pitch black, an eternal void. Why is this? The moon has no atmosphere, no air molecules to scatter the sunlight. Without this scattering, the sky remains a deep, unending black. Light travels in a straight line from the sun, only becoming visible when it strikes an object, your suit, the lunar ground, or your eyes. In the vacuum of space, the sky is perpetually black, regardless of the sun's brightness. The absence of an atmosphere means there's nothing to scatter the light. On Earth, our atmosphere is filled with air molecules that scatter sunlight in all directions, creating the beautiful illusion of a blue sky. In the vast emptiness of space, there's nothing to scatter the light, just an endless expanse of darkness. The bright blue sky we cherish is a rare and beautiful phenomenon, a gift from our planet's unique atmosphere. Most of the universe exists in perpetual night, with stars scattered like distant beacons in the darkness. For astronauts, the sun can be blocked with a mere thumb, plunging them into a profound darkness, surrounded by the twinkling stars of the cosmos. Our blue sky is a unique and precious gift, a reminder of the protective and nurturing atmosphere that envelops our Earth. If the universe is infinite and filled with stars, why isn't the night sky blazing with light? This is Olbers Paradox. In an endless universe, every line of sight should end on a star, making the sky bright as day. But we see darkness between the stars. This contradiction puzzled astronomers for centuries. The dark night sky suggests the universe isn't infinite, eternal, or uniformly filled with stars. The darkness is a clue, evidence that the cosmos has a history and structure. This simple observation led to some of the biggest discoveries in science. Early thinkers like Thomas Digges imagined an infinite universe but couldn't explain the dark sky. Olbers suggested cosmic dust blocked distant starlight, making the sky dark. But if dust blocked light forever, it would heat up and glow, lighting the sky anyway. The dust theory just replaced stars with glowing dust, still a bright sky. These early ideas were important steps, showing the darkness was a real scientific problem. They pushed astronomers to look deeper for answers. The groundwork was laid for future discoveries. The darkness of the night sky demanded a true explanation, and that explanation would change our understanding of the universe. The real answer to the question of our universe's origin came in the 20th century, when scientists discovered that the universe had a definite beginning, a moment when everything we know burst into existence from a single, unimaginably hot and dense point. This event is known as the Big Bang, and it happened about 13.8 billion years ago, setting the stage for everything that would follow: galaxies, stars, planets, and eventually, life itself. Because the universe isn't infinitely old, there's a limit to how far light can have traveled since that first moment. The most distant stars and galaxies are so far away that their light simply hasn't had enough time to reach us yet, no matter how powerful our telescopes become. Light, the fastest thing in the universe, still travels at a finite speed, about 300,000 kilometers per second. This means we can only see what's within our observable universe. A bubble defined by the distance light has traveled since the Big Bang. When we gaze at distant galaxies through powerful telescopes, we're actually looking back in time, seeing them as they were billions of years ago, not as they are today. Our view of the cosmos is limited by both time and distance. The farther we look, the further back in time we see. But there's a boundary we can't cross. The night sky is dark, not because there aren't enough stars, but because there's a cosmic horizon, a limit beyond which light hasn't had time to reach us. Beyond this invisible boundary, the universe continues, but its light is still on its way, traveling across the vast emptiness of space. The universe is unimaginably vast, stretching far beyond what we can see, but to our eyes, it's not infinite. Our vision is limited by the age of the universe and the speed of light. There are only so many stars whose light has reached us, and each one tells a story from a different era in cosmic history. The darkness between the stars is the shadow of the universe's youth and the ultimate speed limit set by nature itself. We see only the light that's had time to travel across space since the beginning, a cosmic message from the past, reminding us of the universe's incredible journey from darkness to light. Before we dive in, don't forget to smash the like button and subscribe to the channel for more amazing space content. There's another twist. The universe is expanding. This isn't just a minor detail, it's a fundamental feature of our cosmos that has profound effects on what we see when we look up at the night sky. As space itself stretches, the light traveling across these vast distances is stretched along with it, a process known as redshifting. This means that the light from distant galaxies is shifted to longer, redder wavelengths, moving it out of the visible spectrum. This cosmological redshift is why much of the ancient starlight we might hope to see actually arrives as invisible infrared or even microwaves, far beyond what our eyes can detect. The further away a galaxy is, the more its light is stretched, making it fainter and harder to observe. The most distant light in the universe is so stretched out by expansion that our eyes and even many telescopes can't see it at all. It's as if the universe is hiding its oldest secrets in wavelengths we can't perceive. Instead, what fills the universe is a faint afterglow, the cosmic microwave background, an ancient light left over from the Big Bang itself. This glow is everywhere, but it's so faint and so stretched that it's invisible to us without special instruments. The ongoing expansion of space continues to dim and hide the light of distant stars and galaxies, making the universe appear much darker than it truly is. When you combine this cosmic stretching with the fact that the universe has only existed for a finite amount of time, it becomes clear why the night sky isn't ablaze with light from every direction. The darkness we see is not just emptiness, it's a relic of cosmic expansion and the universe's dynamic, ever-changing history. Every patch of darkness tells a story of light that has traveled for billions of years, only to be stretched beyond our sight. So the sky is dark not because it's empty, but because its light is ancient, stretched, and hidden by the very fabric of the expanding universe, a silent testament to the vastness and age of everything around us. Our eyes see only a sliver of the universe's light. Most of the cosmos is invisible to us, hidden in wavelengths we can't detect. Telescopes reveal a vibrant universe, glowing star nurseries, ancient afterglows, and energetic black holes. Space isn't empty or dark, but filled with wonders beyond our vision. The dark sky is a paradox, serene to our eyes but alive with cosmic stories. Science lets us peel back the darkness and glimpse the universe's true glory. The sky is dark because its story is vast, its light ancient, and its colors beyond our sight. And that's the real wonder above us.